Hi there. Thank you very much, Patrick, for the introduction. I'm Becky Worledge. I'm joined by my co-host, Corey Pendleton. I've recently come off a long project doing a lot of QML UI work, and there's a lot of animations involved in that. And I'm also pleased to say that Corey has also done a lot of UI work using QML, so we're both pretty familiar with the subject. I also just had a sign come up on my machine saying my internet connection is unstable. So I'm optimistic that this will last for the whole hour, but just in case, Corey will take over, hopefully. So QML animations, declarative delights for imperative engineers. My name is Rebecca Worledge. I'm generally known as Becky. I work for the QT company in Santa Clara. Of course, that's in the west coast of the US, California. It's currently midday here, so I'm guessing in most places it's going to be afternoon or evening. And what I'm going to be talking about today is QML, the basics of QML. So if you're already a C++ developer, if you're already familiar with the Qt C++ framework, and you may well have heard of QML, perhaps people in your company are starting to use it. Perhaps you've heard from previous World Summit of the improvements we're making in the QML runtime, so it's getting faster and getting better all the time. Maybe you've had a look, but you're not quite an expert yet. This is the talk which you need to be in. This is for engineers who love Qt C++, which is, I think, hopefully most of us, hopefully all of us, in fact, and you're looking to get to know QML. And I'm going to do this in a kind of two parts kind of talk. First of all, we'll look at the relationship between C++ and QML, Qt C++ and QML. I'll give you a very quick review of the parts of the C++ API that Qt hooks into and sits upon. This kind of thing, teaching QML to C++ engineers, on the whole, it's about 3 days before they get that kind of look on their face which says now they understand it. So the idea here is to kind of get you an understanding of the basics, how it works, and get that together in less than an hour, actually much less than an hour. Then we'll look at what Qt is, exactly what it is. If you already know that, then do stick around because we've got some cool demos and the like. And the second part, of course, we'll take a look at the animation class, the animation elements in the QML framework. We'll have a very, very quick QML bootcamp where we look at how it connects back to the C++. And then we'll look into animations, we'll look at transitions, QML states, behavior, and easing curves. So hopefully you'll leave with a good understanding of how to go and write animation-based QML applications. If not, then hopefully you'll be able to do it tomorrow, perhaps after some practice. So, okay. So part one, the power of Qt that is leveraged by Qt and QML. Principally, when we look at what parts of QML connect to the Qt runtime, the most important thing, of course, is QObjects. QObjects offer a lot of features. Also taps into the Q event loop, of course, and the Q variants are critical when it comes to running between C++ and QML applications. Okay, so of course, as C++ engineers, you're all familiar with QObjects, hopefully, and you know that QObjects give us a whole bunch of useful things, including memory management. So QObjects, when you create a QObject, you can pass in a QObject as a parent, and that's a useful thing to do because that way the QObject will register itself with the parent as a child. When the parent is later on destroyed, the child objects are also going to have their destructor called. So that will clear up the memory and run a lot of the memory management for you. That's a useful feature which we see in QML. QObjects are also great for handling events. So as I'm sure you know, when you're passing events around your application, be it a widget-based event or a QObject event, it's coming via the QObject event call, and it's coming as a QEvent class or a pointer to that class. The event types are checked, they're handled or not handled and propagated onto where they need to go. That's something which, of course, is also working in the QML or in the Qt runtime, and we'll take a look at that as we get closer to it, of course. And of course, QObjects have properties. So properties are, of course, we have these macros to set properties in the top level of QObject. In the QObject class itself, there are very few of these Q properties, but you will see them in a class like the QQuickLoader. What this macro we see on the screen now, what this does is it allows the runtime to map between the name of a property, say in this case it's a Boolean called active, and the getter and setter methods and the signal to say when it's changed. And that's a useful feature. That's kind of C++. It's also kind of C++, which runs the declarative side. We also have, if you're familiar with the QObject, we have the dynamic and static properties, which are available via the get and set property methods. So there's a get property and a access all the properties set property method. And we use that a lot in QtQuick as well. It's one of the very more important parts of the runtime. We'll get on to how the properties are set in a little bit. First, we're going to talk about signals. Signals in a QObject or in Qt, a signal from a QObject, of course, is the Qt version of callbacks. So a signal is emitted when something from one class needs to tell another class. It's a flexible way to notify of changes or events or anything that's happening in one object to another QObject. So of course, when you create a QObject, a signal in C++, you basically just add it in the header file. You don't actually implement the body itself, because the meta object compiler tool will create that for you at compile time. So it's easy to use in that sense. It's the difficult work happens in the back end, or the complex work happens in the back end, and it's done for you. Signals are connected to slots, and these again we'll see in the QML runtime. A slot in modern C++ Qt5 is mostly it's a fairly normal function or a method, and it can be connected up to one of these signals, these special methods. Slots they connect as a direct connection or as a queued connection. So when you connect your slot to a signal using the QObject connect method, you can either set it as direct, queued, or automatically leave the Qt runtime to figure it out for you. And of course, direct is a direct method call, and queued goes via the event loop. QObjects themselves don't do a whole lot. Well, they do a lot, but they don't do that much without the event loop. The event loop kind of brings to life the whole of the Qt runtime, brings life to your application. So signals and slots, particularly, especially when they're going via the event loop, won't do anything with no event loop. And the event handling and propagation and so on and so forth comes from the Q event loop. If you have used Qt application and used the Qt API but not looked at the Q event loop, a fascinating thing to do is to build the debug version of the Qt libraries and run the Q event loop through a debugger, and you'll get a real fantastic view of how Qt works on the inside. And you don't need to do that to use Qt, but it's interesting to do, and you begin to get an understanding of the relevance of the event loop. Okay. And the final part of the C++, which we need to have in mind when we look at QML, is the Q variant. So of course, a Q variant is a C++ union class provided by Qt runtime to marshal various different types of events or objects and properties and values into a single variant. Most of the Qt core value classes are visible. The actual classes which contain data are can be translated to and from a Q variant. So like QString, integers, and so forth. The char class can all be passed into a Q variant and passed around. Other Qt types that are not part of the Qt core are added in other parts of the C++ runtime. And of course, you can create your own Q variants. You can, when you create your own custom classes, if you need to pass them to the meta type system, if you need to pass them via signals and slots, you can add them to the Q variant recognition system, the Q meta type system. You can leverage that and add your own classes as long as the system basically knows how to serialize and deserialize them. Then you should be good. You can create your own Q variants. While I was researching this and planning this talk, I found that the first Q variant came out in about Qt 2.1, I think, maybe 2.2. And that actually means that Brendan Eich released the first draft of JavaScript slightly before the Q variant, which is interesting because when it comes to running QML applications, of course, QML applications use a lot of JavaScript, and the Q variant maps perfectly to the JavaScript var, as we'll see. It's not clear which one came first, but it's fairly close. So all of this, what does it have to do with declarative programming? At the time the Qt C++ framework was being put together, Qt Quick and QML were not around, and nobody was really considering creating them. It seems that Qt is fantastic for running a declarative framework on because it has all these features. And I think in many ways, it's actually fair to say that any well-designed object-oriented framework will work very well with a declarative programming language approach. Declarative language is basically something you can do if you have a really solid object-oriented framework to build it upon. And what do I mean by that? By that, I mean, let's move on to looking at Qt Quick, and let's look on to looking a bit more at, at declarative programming in general. So another way of looking at this talk is Qt Quick quickly, which is we'll go through Qt Quick as fairly quickly, and then we'll take a look at animations. Okay, so what's Qt Quick and what is it different? How is it different from QML? Well, QML is the meta language, the Qt meta language. So at the moment, it stands for Qt meta language. I think in the past it stood for Qt modeling language and Qt markup language. It's QML. It's the meta describes a Qt application. Qt Quick is, of course, the runtime, which runs the QML applications. So if you've ever used Java, then you'll know that the language API and runtime are, at least when it came out at first, were all called Java. Unlike Java, QML only has one single runtime, and that is Qt Quick. So it's entirely fair to use Qt Quick and QML interchangeably as an application description. Of course, we did have a build system called QBS, and that was basically a build system which used QML to describe the build system. So that was another use of QML, but it's not such a, it's still around, but it's not such a priority these days. Okay, so when you have a Qt Quick runtime, a Qt Quick application, you have various parts inside the actual Qt Quick runtime itself. So we have the QML language parser, which reads the files and creates the various objects, classes from the files. These are then passed to the QML engine. The QML engine, which kind of gets them working and does all the back-end work to connect them up. We have a couple of what I'm calling Qt Quick viewports, so such as the Qt Quick view or the QML application engine. Once you have your QML files, you pass them into one of these, which passes them through the parser and sets up the engine. We also have a JavaScript runtime embedded in a Qt Quick runtime. Currently, it's v4. In the past, there have been others, but currently we're using our own v4. There's a scene graph inside QML as well, which is good to know about. The scene graph in Qt Quick 2, at least, allows it to keep things moving, and it's where all the nodes are created that various different things are held. And the scene graph, of course, has a renderer. So there's kind of two renderers, but effectively, there's really only the one renderer which you'd really want to be using, and that's that they're batching the smart renderer. There is another renderer, but it's not advisable to use it as it will not go as fast. Since Qt 5.6, I think we've had various different scene graph backends. So the scene graph itself renders by the renderer to traditionally an OpenGL or originally an OpenGL. And later on, it's got a Direct2D. It currently has a rasterizing engine backend, and there's others on their way. So as we move forward away from OpenGL applications, we start with rasterizing and we move to Vulkan and Metal and whatever other hardware acceleration is coming in the future. Qt Quick, if you're programming your Qt Quick application, there are actually 3 different APIs you can use. There's the C++ API, the JavaScript, and the QML. And I'm starting with the C++ API because the C++ is kind of key to understanding declarative programming. What we're doing is, well, we'll take a look at the C++ API first. So it starts with QObjects, which is not entirely true. When you say everything in QtQuick is a QObject, it's really nearly everything, because QObject is in a QtQuick application. QObject is where the behavior and the activity comes from. Of course, we have data objects. So we have QVariants as well. So everything is a QObject or a QVariant. The QQuick item is the next key part of the QtQuick C++ API. QtQuick item is anything visible inside a QtQuick application is a subclass of a QtQuick item. There's also an easier to implement one, or a simpler version, called the QtQuick painted item, which uses a QPainter. QtQuick item itself will render via the scene graph nodes. So it's a tree of scene graph nodes in itself. It's more complex, but it's a lot faster. However, we don't recommend you use this unless you have to. If you do create your own classes, you can render them, or you can create them and you can add them to your runtime using the QML register type. I have an example of the code here you would use. If you want to get a closer look at that code, a grep of the Qt declarative source code will show that that QML register type is used in plenty of places to add the various QtQuick items to the runtime. So take a look at that. There's also a QAbstract item model. So if you're familiar with the Qt model view framework already, we have the C++ part, the QAbstract item model works in exactly the same way. And that just plugs into a model, or into the views, QML views like list view and grid view and so forth, in a very similar way. It's almost the same. Okay. So when is the best time to use the C++ API in a QtQuick application? So there'll be times when you need to do imperative programming in any application. So for example, business logic or sorting lists and so on and so forth. You can use JavaScript for these, but of course, JavaScript is not the best language for really heavy lifting. If you need to do something business logic wise, you're a lot better off passing it to a QObject in the C++ side and letting it do the stuff for you. It's a lot quicker. Likewise, if you're creating a performance critical component that needs to run really, really fast, an item which needs to run fast, say some kind of gauge, for example, you could do that using the QQuick item and just subclass that and write it. Again, though, or similarly, if you're using a less performant component, so a small thing like an icon, for example, you may use the C++ API for that and create it with a QPainter and then pass it forward, and that would pass it to the QML. That would be fine. And of course, there's the model view. So let's take a quick look at some code. Let's have a look at some of the C++ API in Qt. And I'm going to start off with the Lottie animation. So I don't know if any of you are familiar with QtLottie. It's a micro animation framework. It's really designed for icons and animated icons. And as such, it only uses a tiny piece of screen area. We're talking 20 by 20 pixels in most cases. And for that, we actually use a QPainter. So it has the paint method here, and a QPainter is passed in. We paint to that painter, and it comes back and appears on the in the scene graph. The painter paints to a texture which gets passed to the scene graph. That's a very simple way to implement a C++ class in QML. More complex, QtQuick rectangle. Yeah, this is mapped to the rectangle element in QML. It's actually a lot more complex than you'd expect. Rectangles actually can have various different features. They can have corners, they can have gradients, they can have opacity. When this runs, it's actually passing in a scene graph node, and it will return a new scene graph node and work directly with the scene graph, so you get better performance. So this is not so simple to implement as a QPainter-based feature. That being said, people do it, so it's not impossible to use, it's just not so quick. And it's available for QML applications that need that level of performance. Okay, back to the slides. QtQuick JavaScript API. So of course, V4 is QtQuick's JavaScript engine. It's the best JavaScript engine for running with Qt. Perhaps not the fastest in the world, because it's designed to run with Qt and designed to run in ways which are slightly less efficient. And there's a reason for that, but it's designed to run with Qt classes. So for running with Qt, it's first rate. There's a couple of differences available in the JavaScript runtime. So we have better support for signals and slots. If you import a JavaScript file, then it will run in its own private context, and so forth. I don't want to spend too much time on JavaScript. This is a talk for C++ engineers, and recommend you refer to the QML menu for that. But yeah, basically you can import them as a JavaScript file, you can embed them in a QML binding or add them as a function. Now, what do I mean by that exactly? Okay, so JavaScript functions. Here's a very standard function. If you've looked at any HTML pages, you'll see this kind of function all over the place. It's basically the keyword function and then the function itself. Very simple. More advanced JavaScript, you'll often see this kind of function where a var is created and then the function is assigned to that variable. This one, you need to do an imported JavaScript file because you cannot embed that in QML directly like that, because you can't just use the assignment operator directly in QML. If you were doing it in QML, you would do it this way with the property type name and then assign the function that way with a binding operator, and that would work. So if we run that in the fourth type of JavaScript we have, so what we have here is a mouse area and we have a signal handler, and that signal handler is happening when the mouse area receives a click. It's running all that JavaScript, and it will just run those functions fairly much the same. We're going to look a bit more at signal handlers shortly, but for now, that's just an easy way to run JavaScript. Okay, the Qt Quick QML API. So here we have a nice piece of QML. I'm not going to go too much into what it does, but basically we have a row, we have a repeater, which is kind of part of the model view framework, and we're passing a model into that repeater. So we have the first element here, oops, did not mean to do that, the row, which goes from the lower curly brace to the top, and the repeater sits inside that. So although it looks like it's JSON, these are actually objects in their own right. So it's definitely a modeling language. It's actually a markup language. We're creating these objects, we're initializing them. The model in the repeater is a property. So if you think back to the QProperty macros we saw earlier, when this is changed by adding this internal display speed length value to it, then the relevant getter, relevant setter rather, is called. And if it changes any values, a notification is also generated, and that will happen in the C++ for us automatically. So I understand that this is something of a fairly quick talk. So if you do have any questions arising, then please feel free to ask Corey. So the most basic item in a QML element, the most basic of the elements is the item element. So if you think back to the QQuick item we were talking about earlier in the rectangle, a QQuick item is that base class for any element with a coordinate in QML. The item does not draw anything itself, but it's useful as a layout guide. It's useful as the base class of everything that gets drawn in QQuick. And behind the scenes, it's the C++ QQuick item. So here we have an item, its width of 100 and its height of 200, and it's just sitting there holding things together for us, I think. No, going backwards, sorry. QtObject is the QML equivalent of a QObject. So you can also embed QtObjects, QtObjects to a QML file, and they'll look kind of like this. It works the same kind of as a item. The only real difference is it doesn't draw anything. I've got a note here about the special property of ID, which is not from the Qt object itself. So you'll see in QML we have every object can have an ID. That refers to a separate tree that's not related to the QObject tree. So if you go back to here, you'll see the item also has an ID, and that's not coming from the Qt object, but all Qt objects will in QML can access that. This is not a typo, this is the binding operator. And this is perhaps one of the most useful features of QtQuick, and you will find yourself using it all the time. In fact, if we look at the examples we've seen so far, we're full of these colons after the property name. When we define a property in a QtQuick item, in a QtQuick file, we give it the property here, We'll then say what type it is, and that's a scalar object like an integer or a real. You can call it a var, so you can create JavaScript variants. And items, we give it a name, and then we set the colon here, and then we can either give it a direct value like 1, 2, 3. We can give it the name of an object there as well, so it will become an object, or we can give it a formula. And the fantastic thing about binding operators rather than assignment operators is when a value that's in the formula changes, then the result is reevaluated, so you'll get to see it changing live in the code. And that's where QML starts to get really, really powerful. Let's take a quick look at that. I have a demo for that to show you some of the binding. Here it is. So this is a fairly straightforward little gauge. It's slightly crummy demo. So we once created a gauge for a motorcycle company, in fact, which had this really cool kind of hockey stick effect. Of course, it's a very nice gauge, but we can't use the actual customer's gauge in one of our talks. So we created our own. And you'll see here, it kind of looks like a hockey stick. And you'll see that as the tachometer goes up and down, if we change the RPM here, it moves up and down. Of course, the RPM is changing somewhere else. And we're actually just animating something inside to create that effect. And what we're actually doing is we're animating a rectangle, and we're using a opacity mask to hide the rectangle and so on and so forth. The key thing I want to show here is not the actual animation though, but the bindings here in this internal Qt object itself. So the value is coming in as the current RPM, and that's being set somewhere in the system. It passes the current RPM into the application. That application, or that current RPM, appears here, where we have various other values. When that RPM changes, the rotation value itself is recalculated and changed, and that's done live and dynamically and automatically for us. So what we see in the UI is we just see the gauge moves. And the advantage of doing it this way rather than using a function is if for any reason the engine is running and it updates less frequently, but there's already a value for the RPM, is it will be calculated immediately rather than waiting for the function to be called. And that is a very, very useful feature indeed. Okay. So that's a binding app demo, not really animations, but we're getting there. The other thing we wanted to talk about before we start really getting into animations is that, so QObjects in QML, we can just give them a signal. If we need to give them a signal, it's just a matter of writing a signal and then the name of the signal and its parameters, and that's kind of the same as in C++. Slots are the same in C++. In QML, they're just functions. So if we wanted to create a function or a slot for an object, we would just create the function. The meta object compiler doesn't look at the function. So if you create a signal, or if you create it in QML, it's not handled by the meta object compiler. You can connect signals and slots. So each signal does have a connect function, as you can see here. So the clicked is, of course, that's a signal coming from a mouse area. You can connect that clicked signal up to the function hi there, for example. You can do that. We don't particularly recommend that because that's kind of an imperative way of doing it. So signal name connect, don't recommend that. Instead, you should use the signal handler. So every time you add a signal to a class in QML, the QQuick runtime will generate the signal handler for you. And as you can see here, we have a signal called signal name. The signal handler, which is generated for you, is on capital signal name. So it capitalizes the first name of the signal, adds the word on, and you get the handler added for you, which is a pretty cool feature. Okay. Likewise, if you add a custom property to an element, so in this case we have a rectangle, it has a color and it has a property, integer count, property and count. When the color changes, then the on count changed signal handler, or the count changed, is the signal which is emitted, and the on count changed signal handler is triggered. Likewise, if we change the width and if we change the property count property, then that signal handler is triggered. Pretty cool. Okay, so I think that ends the introduction to Qt Quick. Let's start looking at animations. So what can we animate in QML? We can animate everything. Broadly speaking, we can animate everything that's a property, but anything that's a property can be animated, although some animations don't make any sense. So something like a string, you can still animate that, likewise with Booleans. Numbers are a lot better to animate, and the reason for that is because when we animate something, we give it a time that it will run, a duration, and a value where it starts and a value where it will end, and we're basically calculating the points along that line where we want it to end. And that's why a number is always going to be better. Integers perhaps not so good, but a real number for sure. Likewise, colors can be animated, and if you've looked at the way colors are defined, they're set of numbers and a coordinate in a logical space, and because of this it's of course possible to animate a color as well, and it will animate the color quite nicely. However, be a bit careful, don't animate too many of them because that's a lot of work for the GPU, particularly if you're animating a gradient, so have a care. You can also animate properties of animation elements as well, but that might not work. And the reason for that is because the curve which is going to animate along, or the line it's going to animate along, is calculated when you start the animation running. So when you change a value while the animation is running, it's not guaranteed that it will change the animation, although it might do. Okay, so how do we create an animation object? So in this case, we have a property animation, and its name is, its ID is animation sample. The duration is 1,500, of course that's milliseconds, so that would be 1.5 seconds. Its target is the rectangle. So when we say target, we're talking about the item which we are going to be running the animation on. So this property animation maps to the rectangle, which we had a couple of slides back, which you can go back and look at sometime. We're going to be animating the properties of that particular file, of that particular item. So when you create an animation, animations themselves don't know anything about the kind of classes you'll be animating on. But because Qt has this wonderful property system where you can access properties dynamically using the getter and setter methods and the properties method, we just need to pass in a string for that property name. So if we were doing one single property like the X, we could pass in the name X, and we could access that property using the Qt object property system. Likewise, the X and Y will work here. If we're doing more than one property, we can pass them in with a comma separated list. And additionally, if we had added our own custom properties in the QML, they would work too. So in this case, we're animating properties X and Y, and we're going from 0 to 720. So over a space of 1.5 seconds. And the final line there, you'll see an easing type is defined. If you're not familiar with easing types, we'll take a bit more of a look at them shortly. But that basically tells you what shape the line is going to be. Will it be a straight line, or will it have a curve in it? In and out is the points in the line where the curve is applied. Okay, so animations in QML, there's a tree, they're objects, of course. So the root class is the animation. You wouldn't generally use an animation directly. We were just looking at the property animation just now. Property animation works on a property of another class. There are already some subclasses of the property animation, so you can aim an animation just to cover colors, or it can specialize in numbers. Vector 3D, of course, that's for fancy core programming. If we look at the line above, we see sequential animation and parallel animation. We'll take a look at those in a minute. And the one just here, the rotation animation, that's a very specialized animation. Rotation animation will, as the name suggests, animate the rotation property of an object, or of a Qt item, which every Qt item has a rotation. We'll take a look at that shortly, I promise. It's a useful one to have, especially in the automotive industry where you're using needles and so forth. Okay, so moving on, QML state machine, transitions and animations. So every QML item, the other thing they have, as long as X, Y, Z rotation, they also have a state property. Every QML item has a state property. In fact, every QML item has a default state property. Its name is basically a black string. We'll take a look at that shortly. They also have a states property, a states plural, and that's an array of state objects, because of course a state is an object which says what the properties are at any particular time. And the states contain property changes. So a state has a list of properties which change when it's in a certain state. And let's take a look at the demo I have here to give you an idea of what I mean by that. Over here. Okay, so when you're planning a talk, you end up doing way too much fancy stuff, but I think this should work. So here we have a kind of looks like a window. If we look up here, you'll see we have a bunch of rectangles. We have R1 in the top left corner, R2, R3, R4, and so forth. By default, the color of these is transparent. Inside each rectangle, we also have a mouse area. And the mouse area doesn't do anything, except the only thing we know is it fills the rectangle and it will respond to hovers. So if I just show you what the application does, when I pass the mouse across, you'll see various things change color, which is nice looking, but how does it work? Nothing's in the rectangles. In fact, what's happening is we're changing the state. So the state has a Boolean to say when it should be shown. And that state also has a series of property changes. So in this case, it's a very, very simple state demo. As we pass the mouse over, when it contains the mouse, the property changes color, and that's reflected here. Okay, very simple demo, but you may say that does not contain any animations, that just changes colors. And you'd be right, because a state change is not an animation. However, another thing every item has is a list of transitions or an array of transitions. And these transitions are called whenever that state is triggered, whenever the state changes. So if we go back to our demo and our sample app, what I'm going to do is I'm going to scroll down. I have added one single transition here, mostly to make it a bit simpler. So if we remove that comment and make that code live, we have a transition. It's a color animation, which will run over the course of 600 milliseconds. We can add from and to states in a transition, but I'm just going to keep this simple by just showing you a transition which happens whenever one state changes to another. If a color change is detected, it will slow that color change down. So rather than going instantly, it will take a duration of 600 milliseconds. So now if we put the mouse over, you'll see, hopefully, because this is coming over the internet, hopefully you'll see that that is a little bit slower. It's not instant anymore. And that's where we start seeing animations at play. Okay. A key place to use transitions is in the model view framework. Transitions are used to animate changes. When something in the model changes, you can then use a transition to make that look cool. So let's look at the demo here. You can see a lot of activity happening in there. Anyway, sorry. So I've got a little demo here called drag to reorder, and this is a fairly simple. So I spoke about the model view framework in QML. I didn't mention list model. There is also a QML version of a model available. All we need to know right here, though, is that we have a list view, which is the QML model view framework. We have given it that list model as its model, and we've made it possible using various drag and drop techniques to reorder that that demo. So I'm going to comment out that number animation for now. So when I run this, now I can click down, it will change color and I can move it. So at the moment, you should not see any animation at all. As I drag this up and down, it just moves immediately. So what I'll do is I'll uncomment that number animation. Number animation is aimed at the property Y. Of course, the Y is the up and down. It's going to take 600 milliseconds. I'm doing it at 600 milliseconds because hopefully that will be easier to see over a webinar. And I'm giving it this here, easing type in out quad. So that's a quadratic equation for easing. So you should see a nice shape. So you'll see it speeds up and it slows down as it approaches. And as I take this one from number one and drag it all the way down, you should see they all do it. And that's a really nice, simple way of adding an animation into a change. With a transition, you can do that with a state, and you can do it with a specific type of activity in the Model View framework. It will run the animations for you. Okay. Of course, you guys are all imperative programmers and declarative programming is new to you. Qt company does not, we won't complain if you mix imperative code with declarative code. You should do it in the right way, but of course, no animation, no application can be purely declarative code. And to make it easier though, animation objects have start and stop methods. They also have a bunch of other methods. They have pause, resume, restart, complete, which you can take a look at later on. They also have equivalent signals, start, stopped, and finish signals, which look like, okay, that's not what they look like. That's a cue to remind me to show you a demo. So I'll go back to my QML Reloader application here. Open that up. Put that over here. Boop. And what I'm going to do is I'm going to open this imperative file here. Go back to where that was. Click on imperative file, and that will load up this guy here. And what I have here is, again, it's a mouse area. And we've created a rotation animation. So we saw the rotation animation earlier. This time it has the name RA, duration 1500 milliseconds. Target is on the rectangle, which is this guy here. So when this runs, then it's going to spin it around twice over the course of one and a half seconds. I've also added a whole bunch of logic in the mouse area so that if it's running, then it will pause it, or check to see if it's paused. If it's paused, it will resume it. If it's not, it will pause it. However, if it's not running at all, then it will run it. So I mentioned that it has a running ra.running, or rather has a running a start method. Sorry, I'm trying to think of too many things. You can call start as a method. You can also just change the running value. So we take it from not running, which we've checked above, to not running. That would be the equivalent of running, and it should just start. So let's take a look. And there it goes. Likewise, if I pause on it, click on it while it's running, then it's checked the pause and called the pause element. And that's kind of a nice demo, but if you want my opinion, the actual application which is running this demo is nicer to look at and much more interesting. So let's skip over to that application itself. It's the QML Reloader application. You may have noticed when I change something in the file here, then it reloads the file by basically dragging it across. So if I go up here and change the color of the background rectangle, wherever that is, and it's actually dragging the whole thing across. I'm making that effect by actually creating the animation object dynamically, which is a lot more imperative. So I've defined the elements somewhere in the code. I'm going to animate in. So if we look for this animation object, that's the property itself, property var animation. We could also do that as an item or as an animation class, but in this case it's a var. And we're creating that dynamically in the JavaScript code. We're then setting all the properties. So we're giving it the target, telling it to animate on the X from 0 to the width. Of course, X of 0 is off screen. So it's dragging it in to 0 from off screen, taking a second to do it, and it will bounce it when it gets here. And then we're connecting up the finish signal to the switch next. And what that does is it deletes the previous one and rearranges the model so it's ready to go again. So that's a nice animation demo. And if anything was to summarize what our talk is about today, I'd say probably that. Anyway, back to the slides. Okay, a couple of final notes to go over before we get on to the questions. There are some types of animations that are basically more animations. So in this, we have parallel animations and we have sequential animations, and there should be a demonstration for that too. So as we see here, we have a little tiny red rectangle in the top corner. We have a mouse area. When I click the mouse area, it will run that animation. And across it goes. I think yeah, okay, I got that slightly wrong. When I click inside the red rectangle, it will reset it. and we can run it a second time using a sequential animation. So let's go through what just happened there, because it's kind of happened a bit quick. I actually wrote this demonstration yesterday, and that happened a bit quick for me to follow. So we're starting off with a property animation to run, and that's the parallel animation, which is down here. A parallel animation is running this number animation on the width, so it's making it wider. It's running a number animation on the height, again, making it wider, and it's running this number animation on the XY properties, which move it to the bottom right corner. Those all happen at the same time. Of course, once the animation is run once, we then change the animation to the sequential animation using the JavaScript, and then run the animation a second time, and you'll see it's running exactly the same series of animations, but it's running them sequentially. So here we see all the animations running in parallel, and it just goes across like that. Click on the red to reset it. Now when I run it again, it will run sequentially. So it goes down, down, down. Nice. So I hope that explains the difference between parallel and sequential animations. There are more things to know about animations, of course. We have a thing called a pause animation. Pause animation is not something which animates a pause. It actually causes a pause. So you would put it inside a sequential animation, and it would put a gap between the steps. You could put that in a parallel animation as well, and it would run the pause parallel to the rest of the steps, so you probably wouldn't see it. There's also a path animation. Now, a path animation animates an object along a path. It doesn't animate the path itself. So you would use that as a way to create movement in a demo. One neat thing about the path animation is you can change the path between runs, so it won't always run the same way. Script action, of course, is an action, not an animation, so it's not animating anything. It's just running a piece of JavaScript. So if you need to run a piece of JavaScript as part of an animation, either parallel or sequential, you can do that with a script action. Similar to that is a property action. So if you just need to change a property before or after you run an animation, you can set the property animation in that animation, and it will change the properties then. Of course, in most animations, you can just change the properties. So might not be necessary, but probably is. Okay, so let's talk about being on our best behavior. States are very useful. Sometimes those states are a bit too much to use. Sometimes a state can be more than you need. It's like a sledgehammer for cracking a walnut, perhaps. You might just want to change a property and have that property look cool. So let's take a look at another option we have called a behavior. So when a property changes, you can then trigger the animation to make that property change look cool using what's called a behavior class. So the demo for this is our Gauge 2 demo. So Gauge 2 is, again, it's a nice piece of code, but it's a copy of something we kind of might have done for our customers in the past. It's a little compass demo. Let's take a look at the code. We have a controller. The controller gives you a model of various different directions you could be heading, and you can then control the direction which the compass should be going. Of course, if you're getting the compass from a GPS signal, then you would just get it as an integer of a heading, 0 to 360. The compass itself is here. In this case, we're handling the heading again in a binding. So when the heading is changed, the binding here is called, this is a more complex binding, but it's still a binding, and that itself acts upon the angle of the compass needle. So the compass needle is here, and it will just, we have various things. Actually, it's not this one, this is the back, this one here. So we have a rotation element. Rotations have an angle, elements have an angle. The origin is set to the middle. So basically what's happening is when this heading changes, we are changing the angle here, and we're running the rotation animation using the behavior on angle. So behavior on angle runs an animation. So we looked at rotation animation previously. If you're rotating something, this is the nicest way to do it because it has a way of setting direction, and you don't need to calculate which way to turn it, clockwise or counterclockwise. The rotation class will do it for you. Let's take a look at how this demo looks. Like I said, we don't have necessarily the finest UX designers in Santa Clara, so we had to make it out of paper, but it runs just fine. As we move it around, you'll see it will go and it will calculate the way to turn, taking the shortest route round. So rather than spinning all the way around, it will just calculate which way it needs to go. And that's a simple use for rotation animation, triggered by a behavior which is caused by setting a binding. We also have a similar kind of flip animation. So if we click here, we flip it to another kind of compass, which works in a similar kind of way. This time it's using a path, I think, and it might well be using path animation there somewhere. But we're just basically moving the path around and moving things along the path to show the direction. Okay, we're coming to the end of the hour, so I'm going to have to perhaps move on to a quick note on easing curves. We've looked at easing curves here. I'm going to refer you to the documentation, but I'm going to refer you to the documentation on the C++ class as well. The Q easing curve has been around since Qt 4.6. It has some very nice documentation, including charts which show you kind of what the easing curve look like. So if you're looking to get an idea of how they work, this is the place to go. Okay, we're just coming up to the hour, so I'm going to stop, give a conclusion. So in conclusion, animations can be used almost anywhere in QML applications. They're centered around changing one value to another over time and along a line. Animations can be given easing curves to change the shape of the line, so you can give it a kind of a curve in the line. They can be triggered in many, many ways. You can run them from JavaScript imperatively, you can run them as part of a state transition, and you can run them in response to a value changing itself. And of course, you can run them as part of a series of other animations. Animations are a very small part of the QtQuick code. If you look at the QtQuick 2 API on our documentation, you'll see it's enormous these days, and animations are a small part of it, but nevertheless, they are an enormous part of a QtQuick application. Thank you very much. The demos which you've seen here are all available online at this here GitHub address, github.com/relocated-qtvc2020.git. If you didn't catch that, then we will arrange for you to get that information. So if you want to check them out, you're welcome to. Do we have any questions? I think we do. I'm going to take a look. Oh my goodness.
Hey, Becky. Yep, we've had a few.
Okay, Curry, what do we have?
We've got a couple here. Does animation run on a separate thread?
Good question. That kind of taps into a class called the Animator class. So animation itself does not run on a separate thread. I didn't mention the Animator class. Animator class, do we have the documentation? I'm going to flip to Qt Creator and go to help. So animation itself does run on the UI thread, but if we look for animators.
While you look that up, it should be noted that in QML, the UI thread is separate from the event loop, right? So there is some multi-threading there to keep your UI running smoothly while processing goes on in the background.
And yeah, and I think maybe this was a bit too ambitious calling this documentation, because now Qt Creator is indexing it. We have an Animator class which will run on a different thread that's not the main thread. It will run on the SceneGraph thread. So if you need something that doesn't block the thread and can't block the thread, then use our Animator classes. They're much the same as animations, but non-blocking.
Along these same lines, someone asked, is the pause animation, does it block the event thread?
No, I don't think it does. I think it just blocks the animation itself.
Yeah.
Yeah, it's not going to block the event thread because, of course, it's running on a separate thread. It'll block the animation. Okay. Not doing well with the documentation, but yeah, look up the Animator, A-N-I-M-A-T-O-R, and you will see that. Next question.
What is the difference between Qt Quick Animations and QtLottie?
Good question. And in fact, we just saw QtLottie came up in the help just there. QtLottie is a completely different framework from the QML Qt Quick animations. QtLottie is kind of similar to SVG, so it's a micro renderer all on its own. So it's kind of, so QtLottie is more like an embedded image in an application, whereas a Qt Quick animation is actually part of the Qt Quick framework in a deeper level.
Someone asked, what is the live reload browser-like UI that you were using to refresh your UI as you made changes?
This one here. So this is I will show you. This is a fairly simple application, and it's available on GitHub with the rest of the demos, in fact. So this is okay, it's closing itself. This is very simple. It's basically, we give this class a file watcher. It's a C++ class which watches the file which is passed into it, and when that file changes, it reloads it automatically. Do take a look. It's built around a file watcher. Works pretty well, mostly, and just animates in the files from the side as they change.
Awesome. Someone asked about the performance of Qt and QML, and is it basically, is it feasible to move some custom painted widgets and general widgets applications over to Qt and QML? And
yeah, we actually hear this question quite often, and it's very difficult to answer that. So hypothetically, yes, it's entirely feasible. We have the Qt controls framework, which I haven't mentioned in this talk, but it's basically a re-implementation of the widgets so that they will run in a Qt application instead. However, it depends entirely on how big your application is, because there's no automatic way of translating Qt widget code to Qt code. You would have to go through the code and physically rewrite it. So separating out the back end and front end logic and changing the front end. So yeah, it might be a bigger job depending on how big your application is.
excellent. We had a question about double buffering for animations. Is there a way to render your UI off screen ahead of time and then swap it in?
Yes, there is in Qt and in the Qt framework in general, but this is kind of out of the scope of Qt Quick. So Qt is a declarative language. When you're developing Qt, you don't want to be thinking about that kind of thing. You just want to be creating the UI. Of course, when you're actually building the whole system, you do want to be thinking about that kind of thing, but it's more a part of the QPA layer and the system itself than actual Qt. So in Qt, there is no API for that, but there is elsewhere in Qt. Hopefully that answers your question. I'm seeing a nice question from Srinivas here. Do we have that? Do you have that, Corey?
I believe I do. I'm looking through.
I saw it earlier from Srinivas Kamath. It looked like a
yeah. It's the difference between QInvocable and slots, and how do the C++ methods get extended? Do they need to be slots or QInvocables? And what type of connection is used between them? Is it direct or queued connections?
So the difference between signals and slots and QInvocables, I'm not sure I actually have any QInvocables in my source code for the demo here. No, I don't. But QInvocable is a way of exposing it to QML, which will then return a value. So if we change this here from legit file changed from a signal to a regular method, and we'll give it a value return of integer. Not a particularly sensible one to give it, but not to worry. So the difference is that's a signal. What am I doing? So the difference is a slot would not, a slot does not generally return a value. It's a void and it's asynchronous. So when you call a slot, then you're pushing a value in or you're sending a signal in, and it's not generally returning, at least not directly. And of course, that's because it's over the event loop often, so it doesn't return a value. If you're using a QInvocable, then it's a way of exposing the method or the method to the QML runtime. So a QInvocable would be generally one which would return a value. So we would have get number. So this value itself, the get number value, is not visible to the QML runtime, as is the QML can only see the method, the signals and slots, and it can only see what's in the property handlers. If we then set that as QInvocable, then we should be able to see it in the source code. So if I go here to main.qml, and I split the screen here. It's called file watcher. So we can't see get number in the main file itself when we try and use it. If we change that to QInvocable now, the code model might not work right away, but it will give us a way of actually accessing that value from the QML. So this is a description in practical terms. In formal terms, I'm sure we can find something better, but we'll look at that another time.
Just wanted to note we're a couple of minutes over, and the next talk on community-driven QML code standards is already started if you're interested.
Okay. Yeah.
And I don't know, Becky, if there's other questions, if we want to stay online or if we want to go ahead and
I am
release.
happy to stay online, but I think we should probably release people and we'll go through your questions and get back to you.
Yep. Thank you all very much for joining us today. And sorry for a few of the questions we didn't quite get to, but please encourage you to reach out to our team, and you can reach out to us via the Qt.io website. And we hope you enjoy the rest of the virtual TechCon and stay safe wherever you are.